Here we go with yet another part of IB questions, specifically paper 1 questions that your teacher might use. And this is on topic 2.3, so everything related to carbohydrates and lipids. Let's just get started. So we can see here, there's a bunch, to basically give you here a bunch of drawn molecules, okay, a bunch of drawn molecules. And now they're asking you which of the above chemical structures represent fatty acids and carbohydrates. So let's go here. A. 1 and 2 are fatty acids. Is this true? So 1 here is a fatty acid. How do we know that? Because fatty acid is a chain of carbons, a long chain, anywhere from like 4 carbons to 20 carbons. Okay, it can be extremely long. Okay, so we got here a long chain of carbohydrates, and at the end here we have a carboxylic acid. Okay, that makes it a fatty acid. Okay, you can see here in this case, this specific fatty acid is unsaturated because it has double bonds, right? So this is still a fatty acid. So far it's true. What about 2? So 2 is not a fatty acid, right? Because we can see at the end, there's no carboxyl group, right? Normally there should be a carboxyl group. Instead, there's a bunch of alcohol groups. So this is not a fatty acid. In fact, this is a glycerol molecule, When you take a glycerol molecule and you put 3 fatty acids onto these alcohol groups here, you can form a triglyceride, and this you learned in this chapter. If you don't know what I'm talking about, make sure to check out the teaching video on that. So this one is wrong because 2 is not a fatty acid. It's a glycerol molecule, an alcohol molecule. Okay, so what about B? B is saying 1 only. Okay, maybe. Let's see. 1, we know 1 is, 2 is not. 3 here looks like a disaccharide. Okay, there's 2 glucose units put together, so it looks like a maltose. And then here we have a monosaccharide, a single glucose unit. So yeah, I think that's true. It's going to be B. Because, oh no, it could be B or D, because B and D is saying 1 only. Now, let's continue with B. Is 3 and 4 carbohydrates? Yeah, I would say so. This is a disaccharide, and this would be a monosaccharide. So I think this one's right. It's probably going to be B. So why is D not correct? Because D is saying 2 and 3. I mean 2 and 4. And we know 2 is not a carbohydrate, it's the glycerol molecule. So it's going to be B. Now here we go. What are functions of lipids? Okay, so this is interesting. There's a bunch of functions you need to know for lipids, okay? You just need to remember them. I'll try to reveal them here. Okay, solubility, density, energy, and insulation, okay? So energy, we can break it down for a lot of energy. We can store it as a nice belly, which we can use later if we're hungry to get food from, okay? Insulation, it keeps you warm, okay? It keeps you warm. That's why big polar bears and stuff have a lot of fat, okay? It keeps them nice and warm in the cold environment. Another one is density. Fat is very dense. Is very not dense. It's not dense at all, which means if an object is not dense, it means it floats. Okay, so if you put like a ball with air in it, it will float really easily. But if you put a rock, it will sink, right? So fat is a lot like an empty ball. It's very non-dense, which means a bear can float really easily. Okay, so it's a cool feature about fat, which is why bears are very fat. And it's not soluble in water. Okay, it is lipid soluble. So those are all the key features you need to know about lipids, their functions. So let's read the options here. A, hydrophilic solvent and energy storage. So true for energy storage. It's used to store energy because we can take it later and make some energy out of it. But it's not hydrophilic. It's hydrophobic. Remember, lipids don't dissolve in water, right? So we call it hydrophobic. Hydro meaning water, phobic meaning scared. They're scared of water, which is why if you put oil in water, it will float to the top. It doesn't dissolve. So the part that makes A wrong here is the hydrophilic part. It's hydrophobic. So B, now they're saying hydrophobic. So that sounds right. And membrane potential. Okay, they don't have any role to do with the membrane potential. This membrane potential, if you don't know yet, this is basically related to charges on your membrane. Okay, but you'll learn about this later. But so maybe if you're at this point, obviously they're considering that you know all the topics for each question. So this one, maybe you'll be like, I'm not sure about this membrane potential thing. So maybe for now, if I was you, I'd keep this in mind and keep moving. Okay, so C, thermal insulation and energy storage. This one we absolutely know is right because we know it keeps in heat and it helps energy storage. So this way we can eliminate B because we absolutely know C is right. And we've never really heard of this membrane potential thing, but we don't know if it's wrong or not, okay? So this is the way you can come across that problem. But like I said, you will know about this when you learn a later chapter on nerves, okay? This is related to nerves, the nervous system. Okay, so that's why it's C. It's very clear, the answer here. So why not D? Again, because hydrophilic, it's hydrophobic, okay? So the answer is C. Here we get another one. Which molecules are monosaccharides? So single unit sugars. Is starch a monosaccharide? No. Starch is a molecule made when a bunch of glucoses are put together. So it's a polysaccharide. What about, so we can just automatically skip A. It's not going to be A. What about B? Sucrose. So no, sucrose is a molecule made when you put fructose. I can show you. When you put fructose and glucose together. So this is fructose, this is glucose, you put it together, we call it sucrose. So it's a disaccharide. So we know it's not going to be this one either. What about C? Fructose. Okay, we know fructose is a monosaccharide. We saw here, it's a monosaccharide. What about glucose? Glucose we know is a monosaccharide, right? This is glucose. Now what about the last option here? Galactose. What about galactose? Yes, galactose is also a monosaccharide. So it's going to be C. Why not D? Because D has lactose and cellulose in it. Cellulose is a molecule made when you put a bunch of glucoses together, a lot similar to starch. There's a small difference between them, but I won't explain it here. And lactose is a disaccharide made by when you put galactose and glucose together, okay? So D is wrong for 2 reasons. So the answer is going to be C. So here we have one last question. What process occurs when fatty acids combine with glycerol to make a triglyceride? Okay, this one I can show you clearly. Okay, so here we have 3 fatty acids, right? 3 fatty acids. And then here we have a glycerol molecule, right? We saw that before, glycerol molecule. Now, these will react together to form a triglyceride. Tri coming from the 3 fatty acid, tri meaning 3, okay? And glycerol, so triglycerol. We have 3 fatty acids on a glycerol, so we call it triglyceride, okay? Now, how do they combine together? They combine together through a process called condensation. Why condensation? Because we know condensation means water vapor, right? The formation of water vapor. So when you boil when it's like really warm inside a room and cold outside, you'll see the window will start having condensation on it, which is basically water molecules, okay? So this is called a condensation reaction because water molecules leave as the reaction happens, okay? So you can see here, the oxygen and the hydrogen from the fatty acid and the hydrogen from the glycerol, or vice versa, well, actually no, just like this, will react and then they will leave. And as they leave, so let me take it away. So as they leave as water, so here we have the water, now this oxygen is going to be missing a bond and this carbon is going to be missing a bond. So now they will move together and make this bond. Just like that. So this is a condensation reaction. So it's the first option, condensation. Okay, it's not decarboxylation. Decarboxylation means instead of a water coming out, a carbon dioxide came out. But no, it didn't, right? It's water. So denaturation, this applies to proteins, not really to triglycerides or carbohydrates. And hydrolysis means breaking apart. So we just saw that condensation is this formation of the glycerol with the fatty acid. Now, if we reverse this process, this would be called hydrolysis, okay? So the answer is A. Oh no, we actually have one more question. Which molecule shows a monosaccharide and a fatty acid? Okay, so let's go monosaccharide here. They're saying 1, 3, and 5. So is 1 a monosaccharide? No, this is a nucleotide, in fact. This you'll learn, this is what DNA is made of, and you'll learn about this later if you haven't already. So it's not going to be A. What about B? Monosaccharide 1 only. No, 1 is not a monosaccharide. How about C, which is 3? Okay, that's a monosaccharide. That's true. Is it the only one though? No, because 5 here is also a monosaccharide. So it's going to be D. We automatically know it's D. We don't even have to check the fatty acid, but we will just in case. So is the only fatty acid here 4? Okay, 1 is not a fatty acid. 2 is not a fatty acid. That's an amino acid. This is a monosaccharide. This is a fatty acid. 5 is not a fatty acid, and 6 is an amino acid again. So yeah, 4 is the only one. So the answer has got to be D. Cool, so that's it for this video. If you want any more questions, just email me, and I basically sorted out all the past paper questions into the individual 11 topics. So if you want more, I encourage you to just email me and I'll get those to you.